everybody, this is Unit 5, Chemical Reactions, Section 1, the chemical equation. So for this, you should have out guided notes with you. You probably also want your periodic table. The hardest part about all of this actually isn't the new stuff at all. The most difficult part of this is just the naming of ionic and covalent substances. So keep in mind that you might need to go back and review the naming of an ionic compound and the naming of a covalent compound, because those are vitally important to understanding this topic, but all the new stuff is actually really simple. So a chemical reaction is a process where substances change into other substances with different properties. So this is, we are creating something new. Chemical bonds are being broken and chemical bonds are being made. This is different from a physical change. This is a chemical change, and we show that using something called a chemical equation. So here's our chemical equation. It's a statement of what is happening in the chemical reaction. So everything on the left is what is going into the reaction, what you're starting with. This arrow represents when that chemical change is happening. So we start with sodium and chlorine gas, and then we are going to make sodium chloride here. So this just shows us what you started with, when the reaction happened, and what you end with. That's the whole purpose of a chemical equation. So everything you put into a reaction is called the reactant, because it's what reacts together. So in this case, our two reactants are sodium and chlorine gas. The reactants are always on the left side of the arrow every single time. You might have one reactant, you might have 5 reactants. It doesn't really matter, but they're always going to be on the left side. The products are always going to be what you make. What is the new thing that you created? And we write that always on the right side of the arrow. Again, that might be one product, that might be 5 products. It depends on what the reaction actually is. So here's where we need to be really careful. Notice that for my substances here, remember for ionic compounds, for NaCl, the reason why I know the formula is NaCl is because it's an ionic compound and the charges have to cancel out. They have to add up to 0. Sodium has a +1 charge, chlorine has a -1 charge. It's going to be really important that when you are writing your reactants and your products that you get the correct chemical formula. If your chemical formula isn't correct, then you have a completely different substance than you thought you did. So writing the correct chemical formula is going to be really, really important. You'll notice on the other slide that we had Cl2. You might be asking, well, how did I know it was Cl2 instead of just chlorine? Well, we have these things that are special gases, diatomic elements. These are specific elements that have to exist as twins. So anytime you see any of these elements, hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, or iodine, I like to call this Brinkelhoff. Okay, bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine. Anytime you see Brinkelhoff, these guys either need to be in a compound or they need to be 2 at a time. They're diatomic, di meaning 2, atomic atoms, 2 atoms together. So notice here we've got nitrogen monoxide plus oxygen gas. The oxygen gas is diatomic, so we have to write it as O2 when it's by itself. But then over here, it's bonded with a nitrogen, and over here it's bonded with a nitrogen. So we don't need it to be O2 all the time, only when it's by itself. And that goes for any of these elements all the time. So what's really important too is how we can read a chemical equation. This is a big difference between somebody who doesn't know science and they don't know what they're talking about, and this differentiates you and makes you sound like you know what you're talking about. So in here we've got our chemical equation, 2NO(G) plus O2G, arrow 2NO2G. Like, when I say it like that, it sounds real dumb. It doesn't sound like I know what I'm saying. So when I write out the word equation, or when I'm saying this, I would say that nitrogen monoxide gas and oxygen gas make nitrogen dioxide gas. Okay, so notice that I said the full name of each substance. I said what state of matter it is. In this case, these guys were all gases. and for the plus sign I said and for the arrow I said makes. So for the state of matter, they're going to be written out for you, either like that, or like that. So we got solid, liquid, or gas. So liquid is only when something has been melted down. Typically we use liquid when we're talking about water. We also might use AQ, which would be aqueous. So that is when you're dissolved in water. So like salt water is NaClAQ, aqueous. And these just tell us the state of matter, because states of matter really do matter when we're talking about a chemical reaction. If I put two solids together, they're probably not going to react. So it's really important when we're talking about a chemical reaction that we know the exact substance that we're using with the correct chemical formula, and that we have the state of matter as well. So when you're thinking about the state of matter, I want you to pay attention to what the word equations tell you. So if you are writing a chemical equation based off of a word equation, they will probably tell you what state of matter it is. If they don't, then use your context clues. If it talks about a powder, then it's talking about a solid. If it says a metal, we know that all metals are solid. Therefore, if it says pure copper, then it's talking about the copper metal. That's going to be solid at room temperature. If it's talking about CO2, we know that carbon dioxide is a gas. Like, use your logic here. Some of them you won't know off the top of your head, but use your logic. Water is generally a liquid. CO2 is a gas. Hydrogen is a gas. Oxygen is a gas. Also, use your periodic table. Your periodic table is color-coded for individual elements. So if it's asking you about a specific element, if it says you've got Br2, you can just look at your periodic table and figure out what state of matter that's in. If it asks you about sodium, sodium is a solid because it's a metal and it's on your periodic table, color-coded as a solid. So use your resources for this. So at this point, you have a bunch of practice problems in your guided notes. Make sure that you go through those. We'll talk about them in class, but you need to be able to write the correct formula. You need to be able to name properly and name correctly, and you need to understand what each of those symbols means. So the last thing I want to tell you is just some of the other ways that what else we could say for those symbols. So when I have the arrow, that means what we make. Like, that's the actual chemical reaction. So when you see the arrow, we saw on the other slide that could mean makes. You could do reacts to form. You could say yields. You could say produces. Those are all appropriate terms to use anytime you see that arrow. Pick your favorite. Doesn't matter. Okay. Anytime you see the plus sign, that would be reacts with, or the word and are generally what you're going to use there. Okay, so these are just various synonyms that you could use in place of each other anytime you see the plus or the arrow. The very last thing is that sometimes it'll tell you, like, okay, I had CH4 liquid reacting with oxygen gas to produce CO2, that's a gas, just using my logic there, plus H2O, that's a liquid, just using my logic there. Okay, so CH4 liquid plus oxygen gas reacts to produce carbon dioxide gas and liquid water. That's how I would say that. The only other thing is that I might also tell you that this reacts to make heat. So if it talks about heat being a product, then just write it at the end as a product. Now, if it says that it has to react in the presence of heat, that means that heat is required in order for the reaction to occur. So sometimes, if you have something that is required for a reaction to occur, but it's not actually being used up, you're going to write it over the arrow. So in this case, I said that heat was required in order for this reaction to occur. I just made that up. That's not actually true, but whatever. And then I would write it above the arrow. Hold on. Okay, so here's another example. I have CH4 gas plus chlorine gas yielding CH2Cl2 liquid and hydrogen gas. So in this case, this reaction only occurs with a catalyst, and the catalyst in this case would be nickel metal. So a catalyst is something that needs to be with the reaction in order for the reaction to occur, but it's not used up in the reaction itself. It's not a reactant. It's there at the beginning and it's going to be there at the end. It's just like an enzyme in biology. So if I have something that we need for the reaction to happen but isn't necessarily a product or reactant, you would write it over the arrow. So this would be where you would put your catalysts. If they say that you need light or heat, that's where you're going to write it. You're going to write all of those things above the arrow, anything like that. Now, if they specifically say it's a reactant or a product, then you would write it on the left or the right side of the arrow, depending on what it says. So now at this point, you should go through and you should finish the rest of your practice problems on the back of your guided notes.